All right, in this problem, we've got another Blair nightmare. This is stupid, but all right. So in this problem here, our character Blair is moving along this line right here. It's the line 2x plus 3, and we're moving at a rate. Here's how our rate's described. The x units are changing at 3 units per hour, and that's 3 units, positive 3 units. So every hour, we move 3 units further to the right. At midnight, we're at 1:5, so that's right here, 1:5, midnight. And we could just call that t equals 0 if we want. And we are asked to find, let's see here, write equations, find out where's Blair at a certain time and what's her speed. So where is she at 9:45 and speed, overall speed, not how much fast the x coordinates are changing, but the overall speed as we're traveling along the line. So let's see, let's start by making a table. So let's see, I've got t, x, y at time 0, we're at 1:5, and we could put in any number of other points here. We need to figure out where we are at time equal to, say, 1. That's 1 hour later. So let's see. If the x units are changing at 3 per hour, so x is going to go from 1 to 4. And say at hour 2, x is going to go from 4 to 7. Okay. So then using our equation, see, just plug in 2 times 4 is 8 plus 3 is 11. And 7, see, 2 times 7 is 14, 17. Okay. All right, so let's check out those points. That's 4, 11, so 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Here is 4, 11. That's t equals 1. And then 7, 17. 4, 5, 6, 7, 11, 12, 13, 14, 15, 16, 17. So here is 7, 17, and this is t equals 2. So our equations, see, we've got plus 1, plus 1, plus 3, plus 3, plus 6, plus 6. So our x, look at our rate of change of x with respect to t. It's 3 to 1, 3 over 1, so 3t, plus our starting point, which is 1, which means that x coordinates start at 1 and increase 3 for every hour, which we were told earlier. Y starts at 5 and increases 6 per hour. So we have 6t with a starting point of 5. So there's our 2 equations. So we can use these to predict where Blair is at any time. And we were asked to find, well, where was she at 9:45? So 9:45, let's think about this. Here we have 9:45, 10 o'clock, 11 o'clock, midnight. So let's see, this is, o'clock, and this is our t value. So t is 0. At 11, we're at -1. At 10, we're at -2. And an extra 15 minutes back from that, 15 minutes is a quarter hour, so that's -2.25. So that is our time. So at 9:45, t is -2.25. So then we said plug that into our 2 equations. Let's put this over here. Position at t equals -2.25, or 9:45. So we have our x which is 3 times negative 2.25 plus 1. X equals, and just punch all this into the calculator, 3 times negative 2.25 plus 1 gives us negative 5.75. And then Y is 6t plus 5. So 6 times negative 2.25 plus 5. I'll just plug all that in to the calculator. 6 times negative 2.25 plus 5 is negative 8.5. Okay. And finally, we're asked to find her speed. So look here, speed would be units per hour, and we know where she is at time equal to, say, 0. There's a location at 0, and here's a location at an hour later. So we just have to pick one unit. We'll find one interval of an hour. We'll find out our corresponding positions, and we'll just use Pythagorean theorem to find the distance between them. And it'll be that distance in 1 hour, or that distance per hour, right, for our rate. So here we have 1.5 and 411. I can draw my triangle here if I want to. So I've got 6 and 3, or 6 and 3 right here. So let's see. Distance traveled in 1 hour. A squared plus B squared equals C squared. We have 6 and 3. 6 squared plus 3 squared is C squared. 36 plus 9 is C squared. So square root of 45 is C. And so that's per hour. So then our speed is square root of 45 units per hour. I think that was the last question. So we're all good here.